Welcome also from my side, and thank you for the invitation today. My name is Liane Krober, and I am going to talk about our journey of ELN implementation at the TH Wildau. I decided to give the talk in English to make it better understandable for a broader audience. However, if something is not clear or you have a question in German, you can always ask it at the end of the presentation. So first, I'd like to introduce a bit where I come from. So the TH Wildau is located in Wildau, which is very close to Berlin, as you can see here. It is a technical university of applied sciences with different technical, informatics, and also economy study courses. So we have around 3,000 to 4,000 students. Here you can also see an area view of the campus. And the newest buildings are located here on the left, and there's also a closer look here and here. And that's also where our offices and labs of the department are located. I work in the Department of Molecular Biotechnology and Functional Genomics. Our head of the department is Professor Dr. Markus Frohme, and that's me. And besides, we have also around 20 postdocs, PhD, master, and bachelor students. And as the name of the department indicates, we deal here mainly with biological subjects, mainly within the fields of medicine, food tech, and environment. My research focus lies here on environmental topics, and particularly the analysis of environmental contaminants with mass spectrometry methods. And that's also something you will notice in my presentation here. So how did we find our way into digitalization? So not long ago, research in our lab was conducted as follows. So first we simply planned our experiments in the office, and then I printed a plan for the experiment on a piece of paper, went into the lab, and then I conduct my experiment. The individual steps are then transferred into the paper lab notebook. The results are then transferred from the lab either by a USB stick or in some cases also by saving data on a server. And then the results are analyzed. Some results are printed in graphs, for example, and are also transferred into the paper lab notebook. So the problem here is that this is always only accessible by one person. So mainly we have a project of a PhD student, for example, and he has sometimes or she assistance by bachelor or master students, but those of course have their own PC, their own paper lab notebooks. So it was quite difficult to supervise those works. In 2019, the head of our department had already contact with SciNote because we had a master thesis that was conducted in the field of ELNs. And that's also why SciNote asked us in the beginning of 2020 to take part in a research project where we had to integrate SciNote as an ELN and also test the integration of an automated pipetting system from Gilson. And this task was passed to a colleague and me, and it went also really fast within a few weeks. And we had an onboarding process with SciNote and Gilson, and then we both started from one day to the other with a completely new workflow. Our basic goals were then to improve our collaboration and also the project organization, simplify our lab work, and mainly do everything without using any paper. And as every ELN, we have also already seen in the other presentations, there are different layers of data organization. And within SciNote, you have in the top layer a team. So we set up a team that was called PAC analysis. So PAC stands for polycyclic aromatic compounds, some kind of environmental contaminants. And my colleague and me were both in this team. And then we decided to create 3 individual projects where we worked together in project 1, and then we had individual projects for each of us. And within those projects, we set up different experiments, and those experiments consisted of different steps, or also called tasks within SciNote. And now we have reached the last layer of data organization here. So within each task, you have then a protocol with your experimental steps, and also your results are directly linked to this task. So the results can be pictures, tables, also MS Office files. And here, in this case, because we used the automated pipetting system from Gilson, we also included here pipetting plans and reports of the automated pipetting process. Besides, you have also inventories so you can link inventory items to this task. Then there's a collaboration with protocols.io, so a public data repository for protocols, where you can look for a protocol that fits your needs, and then you can connect it to your task. Yeah, and as I said, yes, also the Gilson Trackman. There's also the Gilson integration here. So that way our workflow was much more simplified. So SciNote is also a web-based ELN. So we planned the whole experiment again in the office. And then we we planned it in the office, and then we are able to access this with an electronic device directly in the lab, which can be a tablet or a laptop. And besides, we received also a tablet and Bluetooth pipettes from Gilson, and on the tablet there was a special software where pipetting plans can be created. And in the lab, then the pipette is connected via Bluetooth with the tablet, and all pipetting steps, so all volumes, the aspiration, the dispensing, mixing steps is mainly performed automatically. The only task the user has to do is to move the pipette to the right position. That's how it looked like in the lab. So you see over here the pipettes, and then here's the tablet. And on the tablet, you have the software from Gilson. You can attach a holder and then place a microdata plate there. Or in this case, it is a MIDI-TOF MS target. And then each pipetting step is shown. And here it's also indicated with those lights. You see where you have to put the pipette and just press the button that the pipetting step is performed. So when this pipetting is finished, you can create a report, and this report includes then all information about all pipetting steps, but also environmental characteristics, so which temperature and humidity you had in the lab at this time. And this report can then directly upload it to SciNote. And of course, you create also some results here with the measurements, and those results can also directly upload it to SciNote. So you have at the end everything in one place, which is not only accessible by me, but also by other team members. And within this project, I also wanted to compare a bit what the standard workflow and the now new workflow would mean for us for time saving and also sustainability. And when you look here at the red and green numbers, you will see that mostly the digitalized workflow is faster and has a lot of advantages. The only point where it performed a bit less well than the standard workflow was the creation of the protocol. But this is attributed only to the pipetting plan, which you create on the tablet. And this, if you have a completely new pipetting plan, this takes some time. But if you have a workflow that is established and you just want to make small adaptations to your plan, this needs just a few minutes, I would say. So that way you can really, by using a digitalized workflow, reduce the amount of time from 2.5 hours on the left to about 1.5 hours. And besides, you have then all your results saved in your ELN. And here we also needed less consumables and of course no paper. So in the end of those 4 weeks project, SciNote told us we had saved around 255 A4 sheets. Of course, they included here all the results we uploaded there. But I think this is remarkable. And yeah, what happened next, you might ask. So because of this successful project, the head of our department decided that our whole department should go digital. And since collaboration with a bigger team is only possible with a commercial version of SciNote, we created then, or let's set up a premium plan with SciNote, where we had 5 teams, 10 users. And because it was asked, also 2 terabytes of space for saving your data. And this is also the plan we are still using now. And back then, we also decided to integrate ELNs and also a SciNote in our teaching course. For 2 years, we used simply the free version of SciNote, and the students were also quite happy to had the experience there. But in the end of 2021, there was also a classroom plan established from SciNote, where collaboration is even better, because then also more students can work together. Okay, let's take a closer look on the software itself. For that purpose, I included here several screenshots. So if you log in, you will see just an overview of your ELN. So you have here your current tasks on the left. Then you have also a calendar where there's sometimes, when you see here the red point is indicated when you have there a deadline where you have to, a due date where you have to do something. And on the bottom, you also see your recent work. Besides, on the right, if it is integrated in your premium plan, you would see requests for signatures, for example. So if you're a supervisor and have to sign a task, for example. So yeah, then on top, you see also already here the free text search. So that way you can really nice find anything you are searching for. And here on the left, you can switch also the team. So as I said, we have in our plan 5 teams. Currently, there are only 4 established. And then you can also switch the team when you have to work not in the environment team here, but in the food team, for example. So, but we stay now in the environment team. So when you are in your team, you have then on the left other possibilities to select. So the main layer are the projects. So here you can set up a new project or even a folder if you have multiple projects that belong together. And then you have also here your current projects. And for each project, you can assign members of your team. You can also change the visibility only for the project members or the whole team, for example. And then you can simply click it, select your project, and you are led to the next layer of data organization, which is the experiments. Here, it's the same. You can create a new experiment, or you can select an experiment that you have planned or that is currently running. And within this experiment, you already see the dates, for example, you have set here, and also a preview of the individual steps or tasks. And you see also how many tasks are already completed within this experiment. So let's select this one. And after selection of the experiment, you see then the individual tasks for those experiment you selected. And here you see an example experiment to quantify PAHs in biochar samples. And one workflow is here on top, the sample preparation and also the extraction. And here on the bottom, I created a workflow for the analytical instrument. so to set up the GCMS. And in the end, both workflows come together for the final quantification. And you all can also edit this experiment and just with drag and drop put their new steps or new tasks within this workflow and connect them with those arrows. And for each task, you can assign members to do this task. You can leave comments for your colleagues, and you can also see the progress of your work. So here, for example, those two are already completed, whereas this task is currently in progress. And if you select now the task, you're on the final level of data organization here, and you see now your protocol with the actual experimental steps. This is also a basic text template with some additional functions, I would say. So you can either use the text fields, which are not visible here, but I will show later, and just write down all your experimental steps. But you can also import a protocol here with the protocols options, either in an external protocol you have on your PC, or assign a protocol from the protocols repository that is also integrated here in SciNote. So if you remember here, the left options bar, you see here also the protocols option. And here you have your protocol repository with all your team protocols, your personal protocols, and also the external protocols. And this is, as I already said, a collaboration with the platform Protocols.io. Currently, there are over 12,000 public protocols, and there you can just search for any protocol that might be useful for you and select this protocol also to either edit it for your purpose or simply assign it to your task and use it. So here I now selected a protocol that I created by myself. So this is loaded from the protocols repository. And as you see here individual steps with a text field. And here you can also indicate whether you have completed them now in the lab. Here, for example, the rotary evaporation, and also leave comments for any steps you did in the lab. Yeah, and it's also possible here to insert pictures, for example, tables, or leave, as you can see, other attachments. So that one we have also seen before. So this is the top of the protocol, so to say. So you can also set a start date for your experiment and the due date. Here you can assign the users. You can also add tags to easily find this experiment or this task. And you can also assign items from your inventory. And here you could change the status from in progress to completed, or even if you want to request an electronic signature of your supervisor. But this is not included in our premium plan here. So there are further functions in SciNote. So I already said there are inventories. So you can have custom inventory lists. So you can create those inventories completely on your own and also attach files, for example. And recently they also released an update with the stock management. You can create reports to summarize your experiments and results. And this function is also used by us as a lab performance record for our students, so that they do not have to write a conventional protocol. And they really like this because they save a lot of time here. Then there are activity lists to track all changes that user made within SciNote. And SciNote offers also different online courses for the onboarding process, which is also very nice and always part of our teaching program, that the students have to do a course to get used to the software. And this is also quite intuitive, and so actually the students have never a problem to get used to SciNote. And then there's a really great support by SciNote, I have to say. So if there are any questions or there are any problems that arise, that they answer really fast. You have your personal customer success manager. And besides, they also developed a lot within the last 2 years. So nearly every month there's a new update. And as I already indicated, there are several integrations as Protocols IO and Gilson, but there are also further integrations. There's also Microsoft Office, for example. And they have a RESTful API to connect to LIMS or other software. So based on my knowledge of SciNote, I also looked at the results of your analysis of requirements. And I found that nearly all requirements are fulfilled by SciNote. However, I cannot completely guarantee the correctness of my analysis. But for us, I would say it is also most important that we have the export and import functions, that it's also a very simple editor to work with. And of course, also the collaboration and role management. And on the other side, we also needed good documentation. It is important that it is operating system independent, because we are working here with Windows systems, but also Linux-based systems. The free text search is always nice to find something you have done a few weeks before. The web-based access is nice for home office, for example. And also the use for teaching is very useful for us. So finally, I can say that we did our first steps into digitalization by using an ELN and also this connected pipetting system. But there's still a long way to go to integrate further instruments. And as the others also said, it's not easy to convince people to really use the ELN. And it always needs a bit personal disciplines to change the workflow you're used to. But it helps a lot if you have a good support there. And that's also something I think you should consider when you choose an ELN vendor, that you have the support there to choose the right solution for you. So, yeah, and furthermore, you also need the electronic equipment in the lab. So, of course, you need a tablet or a laptop because it's not suitable if you have a normal PC to take it with you into the lab. So, but if you cross those hurdles, you are rewarded with well-structured projects, time savings, a sustainable use of paper and consumables, and especially a fair data management. And I think that's worth it. So, thank you very much.